All right, good evening, everyone. This video is about your homework called Review for Hydrocarbons. So normally in class, had we a whiteboard, I would have done this demonstration there, but I am going to do it here instead, hoping that this week we will have one in the class again, a whiteboard that is. All right. So I'm going to share my screen. And on the screen is the first page of the homework. And the first page, as I mentioned briefly in class, is going to be a cheat sheet, so to speak, for the rest of the assignment. So you'll refer back to this page if you're stuck, or just as a general reference as you go through the rest of the pages. And you'll see why in a moment. So first off, it's almost like you're filling in an answer key here. You'll see, this PDF of the document that you have in hard copy form. And first, what it's telling us is what to go off of for the rest of the assignment. So you see saturated hydrocarbons right here at the top, also known as alkanes, and 3 columns. So the first column is number of bonds connecting carbons. The second column says suffix. And the third column says general molecular formula, which I like to call by its simpler name, the type formula. So first off, saturated hydrocarbons are only saturated because they have the ability of holding as many hydrogen atoms as the combining capacity of carbon will allow. In order to achieve that, carbon can't be wasting bonds by double or triple bonding with itself. Remember, carbon only has a combining capacity of 4, which is actually pretty impressive, but it does only have that combining capacity of 4. So immediately, the carbons that are at the end of the chain on the left and the right are going to have one of their 4 bonds used up by connecting with another carbon. If there are carbons in the middle, if you have 3 or more total carbons in the structure, then you will have some carbons that in the middle that are surrounded on both sides with other carbon atoms. And therefore, those carbon atoms in the middle, the ones that aren't at the end, are going to have 2 of their 4 bonds used up because they will be connected to another carbon both on their left and on their right. If that makes sense. So this first column here, number of bonds connecting carbons, it is going to be 1. Okay. Saturated hydrocarbons are also known as alkanes. For example, methane is the saturated hydrocarbon or alkane, which has 1 carbon in its structure. You already noticed by the name of that the suffix in this case is ane, A-N-E. All right. So anything that you discover in the rest of the homework that is a saturated hydrocarbon, you know that when naming that hydrocarbon, you're going to end the word in the letters A-N-E. The general molecular formula, or type formula, as I like to call it, is, as you learned in the notes on the lecture, CnH2n. That's our root. With alkanes, there's a +2. In this case, N stands for the number of carbons, which will be given to you. So you will know what that is anytime that you need to use this formula. Okay, so that covers saturated hydrocarbons or alkanes. With the alkyl radical, a hydrocarbon radical, once again, you're still going to have single bonding between the carbon atoms. So I put a 1 there. Next, the suffix for any of these radicals is just the prefix for whatever number of carbons you have. So like meth, eth, prop, that sort of thing, followed by YL, sorry, it's written kind of funny, and the word radical. So, for example, if I have a saturated hydrocarbon, ethane, which has 2 carbons in its structure, and I remove one of the hydrogen atoms, I have an open bond. Eventually, I'll attach a functional group to that open bond, but until that happens, this is no longer a saturated hydrocarbon. It hasn't taken on a function by adding a functional group, so it is in this example where we used ethane, losing the hydrogen, it would become an ethyl radical. In this case, there's really not much difference between a radical and a saturated hydrocarbon. It's literally just a saturated hydrocarbon that has lost one of its hydrogens. So I can no longer use the type formula that I did for hydrocarbons, CnH2n plus 2, since I'm predicting a number of hydrogens that will be one fewer than the number of hydrogens in a saturated hydrocarbon. Instead of saying CnH2n plus 2, I will just say CnH2n plus 1. What that will do is it will predict one fewer hydrogen atom than the type formula for alkanes did. Okay. With alkenes, which are unsaturated hydrocarbons, in this case, we have a double bond between 2 of the carbons in the structure. What this does is it essentially wastes bonds between 2 of the carbons so that each of them have more bonds taken up connecting with each other and fewer bonds to connect with hydrogen atoms. So we are predicting fewer still hydrogen atoms, and therefore the type formula will, I guess I'll start with the right column on this one, will be CnH2n plus 0, I guess you could say. Okay. With alkenes, like the name alkene suggests, the suffix is going to be -ene. Remember, the prefix is going to correspond with the number of carbons in the structure, and you learned these prefixes both in Unit 8 of Chem 1, as well as it was repeated, I believe, in Unit 1 of Chem 2. So let's say that you saw a structure that had a double bond in it, and you know that that is going to be an alkene. You would simply count the number of carbon atoms in that structure. Let's say that there are 4. The prefix for 4 is bute, meth-pro-bute, right? So you would say butene in that case. Ene being the suffix, telling us that it's an alkene, which further tells us that we know that there's going to be a double bond in that structure. In general, most of the bonds in the structure, if it's a larger structure, are going to be single bonds. But with alkenes, one of those bonds is going to be a double bond. So that means 2 of the carbons are going to be connected by 1 double bond. Then you have the alkynes. That's where you have a triple bond somewhere in the structure. So I'm going to put a 3 here to remind myself during the assignment that when I see a triple bond in a structural formula, I am going to know that that is an alkyne, another saturated hydrocarbon, even less saturated than the alkenes were. Unsurprisingly, just like the name would suggest, our suffix here is YNE. And the general molecular type formula is going to be predicting even fewer hydrogen atoms. So the type formula for alkynes is going to be CnH2n, same root, but now it's going to be -2. Okay. Now we put it all together. This is what you're going to see on subsequent pages. You'll see a structural formula, molecular and line formula, as well as the type of compound and the name of the compound. This example actually is somewhat incomplete. What you'll be given is one of these 3 items as we go through the assignment. And from that, you will have all the information you need to fill out the other 2 columns. First off, I'm going to start with this example because it is a poor one, and I want to complete it. So in this case, you have been given either the structural formula, the line formula, or you've just simply been given the name and type of the compound. let's say that they gave you the structural formula here. I'm circling it. Okay. So let's say they give you that information, but left columns 2 and 3 blank. You would, in this case, what I would probably do is I would start with that structural formula and I would first count out the number of carbons, and I would start to name it. So there are 5 carbons, so I know, as the right column tells us, that the prefix is going to be pent, because the prefix for 5 is pent. I look back at the structural formula and I notice that there's a double bond in that structure. So that tells me, because I just filled it out, that this is an alkene. So pent is going to have the suffix -ene, indicating that this is an unsaturated hydrocarbon with 5 carbons in its structure. Okay, just that word alone tells you that information. And since pentene is an alkene, pentene is the name of the compound, but the assignment also asks you for the type of compound. So pentene is an alkene. It's an unsaturated hydrocarbon. Okay. Now, the molecular and line formulas. The problem with this example is that they're only showing you the molecular formula, but I want you to include both wherever possible. So the molecular formula, you recall, will tell us the elements in the compound and the number of each of those elements, but it's not going to tell you how to place that in a structure. So you see here the molecular formula, C5H10, right in the center column here. I'm circling it right now. That tells you that there are 5 carbons and 10 hydrogens in the structure, but it doesn't tell you where to place those. Now, thankfully, from the information we already garnered, the structural formula that was provided for us, as well as the type and name of the compound, we know that there are going to be 5 carbons and 10 hydrogens, but how to place them, we would go back to the structural formula that they provided, and we would see that on the left, well, actually, you know what? This one actually, because it is so simple, I guess the molecular formula would just be fine. Yeah, we don't have a functional group in this, so my mistake. I think it'll do fine just with the molecular formula there. So first off, I'm going to tell you not to do the first problem on page 2. It's not difficult. I'm going to do it for you right now as an example, but it's not one of our straight chain molecules. So you remember we have aliphatic or acyclic compounds where the carbons are left to right, and they don't form a circle. It's like my analogy in class, like a bicycle chain that is snapped. Now it's an open chain instead of a closed chain that makes the bicycle useful. This is an example of a benzene base, an aromatic compound. So it's a little more difficult to draw. That's why I'm going to do it for you. So C6H5. Whenever you see C6H5, for future reference, you know that ratio of carbons to hydrogens seems very low. And indeed, it's because we, in the benzene structure, you have alternating double bonds, so there are fewer opportunities for carbons to attach to hydrogens, so that's why there aren't as many hydrogens. So, but with benzene, you have your 6 carbons. Carbon 1, 2, 3, 4, 5, 6. I'm drawing on the sheet here. Okay. Instead of drawing the alternating double bonds, you could put an oval in the center indicating that those double bonds are there. Or I'm sorry, that those alternating double bonds are there. Then, again, reading this molecular formula, I see that there are 5 hydrogens. So I'm going to draw them off of the carbons. That one's kind of squeezed in there. Okay. And I've drawn my 5 hydrogens. Then this formula tells me to draw CH3. Okay. CH3. Essentially, this is a, oops, sorry about that. Essentially, this is a, oh, that's still drawing. Okay. I'm just going to move this up here. Essentially, you have a methyl radical that is attached to a benzene ring, an open spot on the benzene ring. Okay. And unsurprisingly, this is going to be called methyl benzene. It's one of the names. Okay. And it's a couple of different things, but when you write the type of the compound, maybe you just say, for this one, an aromatic. Okay, sorry about the handwriting and drawing with the stylus here. So then I'll do one more because one more at least in this section, because this is a more typical problem that you'll see. So here we are given the molecular formula C4H10. And that's all we are given, but that's enough to go off of. So first off, I'm going to draw structural formula. Oh my, this thing is not drawing very well. There we go. Okay, so it tells me to draw 4 carbons. It says C4, so I'm going to draw 4 carbons all next to each other, just like that. And then it tells me to draw 10 hydrogens around those 4 carbons. So what I'm going to do, I'm going to keep them all single bonds right now. But if there aren't enough hydrogens, then that would indicate to me that there's probably a double bond in here, or even a triple bond. But as I draw my lines around the carbons, I'm now noticing that I've drawn 10 lines indicating those bonds. I've noticed that all the carbons now have 4 lines around them. So each one of them has exactly the combining capacity that carbon requires. So when I draw my hydrogens, it just confirms that when you have a hydrocarbon that has 4 carbons and 10 hydrogens are surrounding those carbons, I can see right now that this is a saturated hydrocarbon. So for the type, I know this is an alkane. And for the name, I count the carbons. There are 4 carbons. Meth, eth, prop, bute. And bute is going to be my prefix. And because it is a saturated hydrocarbon, if you don't remember, you can go back to page 1 that you just filled out and look under saturated hydrocarbons or alkanes, and you'll see that the suffix used is ane. So bute for the number of carbons, ane for the fact that it is an alkane or saturated hydrocarbon. So there are several problems like this where they give you the molecular formula and nothing else. Then we get into a section starting at the bottom of page 3, where they give you just the name of the compound. Here, you will need to finish that column. Methane is going to be saturated hydrocarbon. How do I know? Because I see the suffix of ane, which means that it is a saturated hydrocarbon, an alkane. Which alkane it is determined by the prefix. So which alkane is it? It's methane. Methane's given to you, but you need to put the type in here. So what type of compound is this? It is an alkane or saturated hydrocarbon. And what is the name of it? Well, that was provided. The name is methane. So the molecular formula here for alkanes, remember, is CnH2n plus 2. Okay. For methane, I know that there's 1 carbon in the structure because meth means 1. So I know that N is going to equal 1. So this formula becomes C1H2 times 1, because 2N, right? And then we were told to say plus 2 after that. Simplifying this, we get rid of the 1 after the C, because Just the fact that C is there is evidence enough that carbon is in this structure and that there's one present. If you want to keep the one in, it's fine. But yeah, we take that out. So now we are onto our H. And if you look, 2 times 1 equals 2, right? And then if we're plussing 2 to that, that equals 4. So CH4 is the simplified molecular formula that results from putting in this formula. So the molecular formula is CH4, which I just worked out there. So to draw the structure, I read the molecular formula left to right. In the case of methane, you can read it up or down as well, or right to left, because it is such a simple structure and it's symmetrical. But I'll draw my carbon. That's the only carbon to draw. And then it's telling me to draw 4 hydrogens. Well, that's convenient because carbon has a combining capacity of 4. So carbon sitting by itself had 4 bonds that needed to be filled. And since we were told to draw in 4 hydrogens, those hydrogens are fulfilling that need that carbon has. Okay, so that's how you do those problems. Then finally, if you go to page 5 somewhere, there we go, page 5, it's giving you structural formula, but it's not giving you the center column or the right side column. I'm going to go to this first structural formula. This one's really easy. It looks hard, right? But it's not. This first structural formula, I see 3 carbons. Right off the bat, I can do part of the third column's work. If there are 3 columns met at prop is going to be the prefix in whatever this compound ends up being. I can already tell what kind of compound it's going to be as well, because now I look at the bonds. I see that there's a triple bond between the first carbon and the second carbon in this structure. With a triple bond, that means it's an unsaturated hydrocarbon. And specifically, it is an alkyne. Alkynes are when you have a triple bond. So the name of this is propyne. Propyne is an alkyne. So the type is alkyne. See, that wasn't so hard to fill in that third column there. Now the molecular formula is pretty easy too. Sometimes you look at the structure, it looks complicated and it makes the rest of the question seem difficult, but it's really not. The structural formula is provided. So the molecular formula, you simply just read the structural formula. You'll start with the carbons, because that's just what we start with, okay? And you see that there are 3 of them. Okay, so you just put a 3 subscript. Then you just count out the hydrogens. There are 4 hydrogens. There's 1 connected to this first carbon. And then because of that triple bond, these 2 carbons don't have room for any other hydrogens. So then we, though, have a single bond to the last carbon, and it has 3 hydrogens surrounding it. So the molecular formula is C3H4. There is another one on here that I don't believe I need you to do. Yeah, this very last one on, what page is this? 6. So all the way at the back of your the back of your packet here. This is actually a benzyl, or sometimes called an aryl radical. Okay. It's based off of benzene. We could say benzyl radical there. Basically, this is benzene, but where this hydrogen would be connected, you see that there's an open bond. So this is just an aromatic aryl or benzyl radical. It's just benzene where we've lost one hydrogen. So really, this is actually simpler than it looks, but because it's a cyclic or an aromatic compound, I know it seems a little more daunting. So the molecular formula, though, really easy. You just count out the number of carbons. There are 6, and then you count out the number of hydrogens. In this case, because we lost 1, there is 5, or R5. So that is a quick tutorial, and actually a significant amount of work done for you on this particular homework. Please feel free to reach out if you have any questions. Otherwise, I'll see you when we return to class on Tuesday. Thanks.